intro to cosine law. I didn't do attendance yet. I will find the time. Okay. So recall angle, angle, side, angle, side, angle, side, side, angle. There was a pair there. We use sine law, right? Two other cases you may encounter would be the triangle where all three sides are known. It's called the SSS, right? Side, side, side. Or a triangle where you will know two sides and the angle in between them. This is called SAS, okay? So that's the SSA, right? There are two sides that you know and an angle. But in this case, you will know the pair. There will be a pair there. When it's SAS, you kind of sandwich that angle between the two sides. So that's very important. Like when you notice something like this, you have to use cosine law. So either remember these two cases, or just remember that if there's no pair, you're going to have to resort to cosine law. Right? So those are your options there to help you remember. Okay. So we're going to talk about this case first. Case where you have SAS, right? So again, you have a side, the angle, and the side, right? Given triangle ABC, we could draw it like this, okay? It's kind of like the standard textbook version of a triangle, and you can clearly tell it's not right, it's oblique. Okay, so you have A, B, C, and therefore there's lowercase a, lowercase c, lowercase b here. And this is how I'm going to start. I'm going to use a different color, so if you have at least one other color on you or a pen, maybe this is when you want to use it. So I'm going to give you three variations of the same formula, okay? So, and you want to have this on your study sheet. So if you were to write it and a squared is on the side here, so a squared is equal to b squared plus c squared. It looks like Pythagorean theorem at first. Minus 2 times b times c times cosine, and here you're going to use the other color again, cosine A. So why I'm emphasizing this is because if it's an SAS, the goal is to find the side that's across the angle, okay? So this side, if you want to find side A, then you better have angle A at the end here. Alternatively, if you are trying to find B, the side B, notice how this changes. You would have A squared on this side, C squared, so it's basically the other two sides that remain, okay? Minus 2 times B times C, hold your horses, sorry. 2 times A, right, so it's these two sides that show up again here, times cosine, here's your other color, capital B, so angle B is going to be there. C squared, C c squared is going to be equal to the other two sides, which is b squared plus a squared, right? So I kind of flipped it on you. 2 times a times b times cosine of c. Okay, so always noting that angle A, side A is over here, angle B, side B, and angle C, cosine, and angle C across, right? Side and angle across. And in between, right, if A is here, you're going to have B and C here. And it's going to show up again here, B and C again. If you have B squared there, then it's going to be A squared C squared. And you have AC multiplying. And the order doesn't matter. Okay, you can flip the A and the C and you'll know that. I will do that later on. Okay, the order doesn't matter. And so these are the three variations of the cosine law. Okay. Add to study sheet, right? Make sure you have maybe the triangle and at least one variation of it. Okay, you don't need to have them all. Case where you have the three sides known, right? So this would be a triangle like this. If you think about it, if you know all three sides, all you have left is to find an angle. Okay, you need to find an angle now. So just so you know, this formula up here, that's what I'm using to give you the formulas for this scenario, because now you're trying to find an angle. So let's take the first row up top and rewrite it. So you would essentially write it like this. Cosine of A is going to be equal to, draw a longer line like this. Okay. It's going to be b squared plus c squared minus a squared over divided by 2 times b times c. That's the first one rewritten where you isolate for cosine of A, and at the end you're going to have to take the inverse. Okay. Second version of it, cosine of B is going to be equal to, and watch, like I'm going to do this. I'm going to have a plus here, so this plus this minus something else. That's always the pattern, plus and minus, right? And now you want to find angle B, so you're going to have B squared here for sure. That's the most important step, to subtract the side across the angle. And in here you have A squared and C squared being added. And you're going to have to divide this by 2 times A times C. So B, the side B doesn't show up again. It only shows up once subtracting here. So make sure you have this one written down correctly. Okay. Cosine of C would be B squared plus A squared minus C squared over 2 times B times A. It doesn't matter if it's AB or BA. So those are your three versions. So this is the one you want to use. One of these you're going to be using if it's a SSS scenario, and you're going to want to use one of these three if it's an SAS scenario. Okay, so there you have it. I'm going to wait a little longer. Maybe I will add a note here. The numerator can be negative. Remember that. Right? This means that the angle will be obtuse. That's what that means. So if you plug this in and you get a negative, it's like, whoa, what happened with a negative? I'm not used to negatives. What was that? That was IPR stuff, right? No, it happens. And that just means that your final answer will be greater than 90 degrees. Okay? And of course, it goes without saying that you should add these to the study sheet as well. How much longer? I think that's long enough. Okay. All right. First, I'm going to do an SAS. You're going to solve for an unknown side. You have a 70-degree angle here. You have a 5 centimeter side here, 8 centimeter side there. We'll call this example 1. So right side angle side, no pair, right? No pair. So it's cosine law. There's no way you can get a pair out of this, no matter what you do. Okay? You don't have to tell me this, but it's a good note to make, right? And we're gonna label this as well. Okay? So we're gonna go D, E, F like this. We're gonna go clockwise. Okay? D, F. Therefore, this side right here that we're trying to find is D. Okay? So what you want to start with is that D squared. I know you don't have a D version in your notes, right? But the pattern is still the same. If you want to try to find D, you start with D squared. And that'll be equal to the other two sides, which is be E and F, right? This is F, and this is E. So that'd be E squared plus F squared minus 2 times side E times side F times cosine of angle D. See? So I want you to focus on the pattern. So now substitute what you know. D squared is still unknown. E is 8, so we're going to go 8 squared plus 5 squared. And this doesn't matter. The order doesn't matter. If you had gone 5 squared and then 8 squared, you'd still get the same answer. Minus 2 times 8 times 5 times cosine of 70 degrees. And now you got to grab your calculators. I'll show you a couple of tricks here. So you can actually type all of this in one shot if you do it right. Okay, so you go 8x squared, which is 64, we know that. 5x2, right, that's 25, minus 2 times 8 times 5 times cosine of 70. You can do it all in one shot. Okay, and so try it, and you should get that. So D, I will jump that step, right? D is going to be the square root of, right? Because this is D squared, D itself will be the square root of what you just calculated. So this is what you do, 61.638, and it just keeps going. We're going to use all the decimals. So D is equal to, so you go second and press X2, and then you just go up and copy the previous line into it and hit enter. And you get 7.85. We are in centimeters. And if you did this right, there are two things that you can conclude, or you need to make sure that, right, does it fit the bill, right? It's 5.8, 7.85 kind of does fit the bill. So we know that E is the largest angle because it's across the longest side from what you know right now, right? Because it's 8. Right? Another thing is that you now have a pair. Does that make sense? You now know this side and that angle. So if you wanted, if they asked you to solve the triangle, you could now switch over to sine law and continue with sine law from here on in. All right? And so I'll make a note here. You can use sine law to solve a triangle if you'd like. Okay. Example 2. We'll do one more, and then I will move on to the other case. And I'll make a remark before we start. Right? Note, obtuse triangle, right? Comma, angle Y is greater than 90 degrees. Okay? So that's a note. Another one is try, right? Cosine of 103 degrees, what would you get there? Use your calculator. Here. Cosine of 103 is negative, right? Keep that in mind. I will explain that a little later, right? But it's a negative. So it's negative 0.224 and it keeps going. So cosine of an obtuse is going to be negative. This is the note here. Notes are important. I usually do them because it comes down to understanding the concept later on. But it's almost like with technology nowadays, a lot of these nuances are no longer an issue. So you want to solve for y. I am going to skip the step where I write out the formula. I will just say, if I want y squared, okay, I'm going to have to take the other two sides, square them. Could be a decimal, could be whatever. And then I'm going to have to go minus 2 times 13 times 26 times cosine of, do not use Pythagorean theorem to solve questions like these, please. Okay, doesn't happen very often, but sometimes students blank out. So it's 103. If you know anything about double negatives, right, this is like a compound multiplication here. It's like this times this times this times this. Cosine of 103 is going to be a negative. It's going to give you a negative answer. So that negative coupled with this negative here will turn this whole expression here positive. So if you do this in steps and you don't account for that, it's going to give you a problem. You're going to get it wrong. If you do it like I will show you, you just type everything in one shot, it's not going to be an issue. The calculator will take care of that. Okay? But I still need you to know that just in case. So y is going to be square root of, and we're going to figure out what that is. 13 squared, 26, oops, squared, minus 2 times 13 times 26 times cosine of 103, close bracket, enter, 997.06, and it keeps going. I'm going to take the square root of, just copy it, that's 31.58, and we are in inches. There's your answer. So what sometimes it has happened, students do this separately. They find out what 13 squared is, they write it down. They find out what 26 squared is, they write it down. Then they go minus this times this times this, and they figure it out, but they forget that there will actually be a double negative. So they actually end up subtracting that last expression, whereas really you're adding it because of the double negative. So that's the little thing you need to watch out for, except for if you type it in one shot, then it's not gonna affect you one bit. Okay. All right. So this is SAS 2 scenarios. I had one with obtuse just to make that point. Okay. And now we're gonna do the SSS. Okay. Finding angles using cosine law. Example 1. Determine the measure of the largest angle. X is equal to 3.1 centimeters. Y is equal to 2.8 centimeters. And Z is equal to 2.4 centimeters. In triangle XYZ. No diagram provided. So you're going to draw a diagram that is not to scale like that. You're going to go X, Y, Z. It doesn't matter if you go clockwise, counterclockwise. This is 3.1. This is 2.8. And this is 2.4. Largest angle is across longest side. Keep that in mind. It's going to save you a lot of grief sometimes. In fact, there's another note. If given SSS case, always find largest angle first. I'm not going to explain that right now. It will take too long, but just trust me on that. Always find the largest angle first. If you, by whatever reason, happen to take grade 11 pre-cal, you're already there, you know why, right? But other than that, the grade 11 pre-cal has the same unit. They do the same thing we do. All right. Okay. So we want the largest angle. We need to find x, right? Angle x is the largest angle. You don't have a pair, no angle whatsoever. There's no way to get a pair. So you know you're going to have to use cosine law. This is the most obvious one, guaranteed cosine law. And we want to find angle x. Okay? So we're going to start like this. Cosine of angle x is going to be, make a long line. It's okay for it to be longer than what you're going to need. And then leave a little bit of space, go plus, leave space, go minus. You know you're going to have to go minus x squared. That one has to go there, whatever's across this angle. And then you just use the other ones. You go y squared plus z squared, right? It doesn't matter which one goes first. And you're going to go 2 times y times z down here. So these two come up again, but not squared. Okay? So let's go and plug in. So cosine of x, which you're trying to find, is equal to 2.8 squared plus 2.4 squared minus 3.1 squared, all over 2 times 2.8. I'm going to use brackets, otherwise the points and the times is going to throw you off. Like that. At this point, I go equals to right beside it. You're going to compute this, write it down. Compute this, write it down. All decimals. Okay, so let's go grab our calculators. Right, you go 2.8 squared plus 2.4 squared minus 3.1 squared. It equals, and that's 3.99. Most of the time you'll have maximum of 4 decimal places, most of the time. 2 times 2.8 times 2.4 for the denominator, and that's 1344. So I allow you to do that, okay? In the future, you can skip the formula. You go straight to this line here that we're doing right now and just do that, okay? And then the last line here is angle X is going to be cosine inverse of that. Can I divide this and just go 0 point something something? Yes, you can. It's really up to you. But watch what I'm going to do here. Second, cosine. Make sure you use cosine, not sine. Okay? I have some students, beautiful work, everything is perfect, but then at the very end you use sine instead of cosine. So you can go 3.99 divided by 13.44. And you would use all decimals. So if you need to go copy those values, you go ahead and do that. Make sure you close brackets and you get 72.73 degrees. Okay. 2 decimals and you're done. You have a pair. Can use sine law to solve triangle. If you want to, if you like cosine law, you can use cosine law over and over again to solve all of the angles around it. Okay. Example 2. Solve the following triangle. That's what FF stands for. I'm going to run out of room here for sure. So I'm going to continue next page. Triangle fun, F is equal to 7.8 inches. U is equal to 4.4 inches. N is equal to 7 inches. Okay, so triangle fun, right? So you go I'm just telling you to solve the triangle. And at this point, I'm hoping that you remember. It's like, where do I start, right? Find the largest angle first. Unless the question says go straight and solve for this angle, right? Then you abide by whatever the question is saying. But in this case, they're leaving it open, so it's up to you. So I will solve for, I'm looking at the sides. This is the longest side, so angle F is going to be the largest angle. So cosine of F is equal to plus, leave some space, minus. And you have to add if you need to, right? So 7.8 comes back here for sure. And then the 7 squared and the 4.4 squared go in here. Bottom is 2 times 7 times 4.4. Don't square it. And I'm going to use brackets because I don't want you to mix up. So it's actually as simple as that. You identify the angle that you need to find, you plug in right away, and you get the top gives you 7.52, the bottom gives you 61.6. Next line is angle F is equal to cosine inverse of that. So you need to make sure when I assign stuff now that you learn how to use your calculator to get the answers you're supposed to get. Okay. Angle F is 82.99. Notice that we knew this wasn't going to be obtuse because we didn't get a negative. The only chance to get a negative is on the numerator here, turning that whole fraction negative. So watch out for that. Doesn't happen very often, but it does happen. So now I have one angle, I have a pair. Okay. I'm going to continue with cosine law. Okay. So now I'm going to solve for angle N. So cosine of N, just because we need to practice this, right? Plus, minus. Across from N is the 7. And then the other two sides, 4.4, 7.8, go there. 2 times 4.4 times 7.8. That gives you 31.2, 68.6. N is cosine inverse of that. Angle N is 62.96. Keep in mind, if you use sine law, and I maybe challenge you to do that, this may be off by 0.01 maximum. Like you'll be off, but not by much. And last but not least, we need to find angle U. And we have two of the angles already. So we're just going to go ahead and use that to our advantage and come up with 34.05. Let me just check if there are word problems here. Yeah. Okay, good. There's one question that throws students off. A grandfather clock. It's one of those old clocks, right, that your grandfather might have, right? And it swings back and forth like this pendulum here. It swings back and forth, right? So you can kind of see that there'll be a triangle created there. Okay. Anybody have those at home? They make this every hour. They'll make like a gong or something like that. They'll make a loud noise. And then at midnight, you hear it 12 times. So when I had a sleepover at my grandfather's place, good luck sleeping, right? It's just like 12 times at midnight. And then it starts again at 1 o'clock and then 2 at 2 o'clock. And it's very loud. Anyways, that's a little bit of a side note. I digress. So that's your homework. So I'm not going to give you extra, but I am going to do trig A review next. And I don't know how much time we will have. We only have Thursday, Friday before our test. Okay, so it's basically going to be word problems, like word problems, a lot of word problems. And so trig A review, you have trig A review, trig B review, and trig C review. Trig A review starts mixing it up already. Sine law, cosine law. That way you're not just doing cosine law or just doing. So I'm going to post the answer key and this worksheet in case you didn't get it as well. So you have a little bit of extra time. I know we need the time off. 23rd. Oh yeah, is that not next Monday? Phew. Okay. Never mind then. I'm panicking for no reason.